Welcome back. Today we'll be looking at sets of numbers. We have two objectives to cover. We want to recognize common sets of numbers and classify numbers in the appropriate set. We have 5 sets of numbers we will be examining. They are the natural numbers, integers, rational numbers, irrational numbers, and finally the real numbers. Our first set is the natural numbers. If I ask you to count for me, most of you would naturally, and I want you to hear that word, naturally begin by saying 1, 2, 3, 4. Well, it turns out that that is exactly what the set of natural numbers consists of. It starts with 1, continues on with the whole numbers infinitely far toward the positive direction. Our next set of numbers is the set of integers. This set contains the natural numbers that you just looked at, their additive inverses, which is nothing more than their negatives, and the number 0. Here's what that set looks like. Notice that it continues infinitely far to the left toward the negative numbers and infinitely far to the right toward positive numbers. Our next set is a set of rational numbers. This one gets a little bit more complicated now. It contains all of the integers that we've just looked at, all fractions, and all repeating and terminating decimals. I can't list all of these for you, but I can give you some examples. So let's look at these examples a little bit more closely. As we look at our examples, we would like to notice first of all the integers. Let's begin by looking at the number 2, which is an integer, the number 0, which is an integer. Are there any others? Well, sometimes integers can disguise themselves. For instance, I have here negative 50 divided by 2, which is nothing more than negative 25, which is also an integer, and I have the square root of 25, which is nothing more than 5, which is an integer. The next group we would want to look for would be the fractions, so let's continue looking. I see a fraction here of 1/3. I see a fraction of negative 1/4. If you had included this number as a fraction, that's fine. And I also see 22 divided by 7. So I have those 3, possibly 4 fractions. Then we also need to look for repeating and terminating decimals. Here I have a repeating decimal. We'll know that because we see the bar above the last digit. And I also have a terminating decimal. It is not rounded. It simply ended at that point. Our next set is the set of irrational numbers. This set contains non-repeating, non-terminating decimals and square roots whose radicand is positive and not a perfect square. Once again, I cannot list them all for you, but I can give you some examples. The first examples are pi and e. Those are the non-repeating, non-terminating decimals. Many of you recognize pi as 3.14, but let me remind you that the number does not end there. We simply truncate it for the sake of applications. The number e is similar to that in that it does not repeat and does not terminate. Some of you may know it as 2.718, but let me remind you, if you don't know e and you're not familiar with it, we'll save that little tidbit for later on when we get to logarithms. The other group that is included in the irrational numbers are square roots whose radicand is positive and not a perfect square. Let me remind you, the radicand is the number underneath the radical. So in this one, it is a 3. That number is positive and not a perfect square, so the square root of 3 is indeed an irrational number, and as is the square root of 17. I'd like to add one more number in our list, and I'll ask you this question. I'm adding the square root of 16. Does that number belong in this list? What I need you to be thinking is that 16 is a perfect square. Therefore, the square root of 16 is nothing more than 4. It would be appropriate for you to tell me that that is an integer. It would be appropriate for you to tell me that that is a rational number. It would even be appropriate for you to tell me that it is a natural number. But what you cannot tell me is that it is an irrational number. So that number does not belong in our list of irrational numbers because it is a perfect square. Our next set of real numbers contains both rational and irrational numbers. They're the real numbers. Here once again is a list of some examples of real numbers. We said it contains both rational and irrational numbers, so let's glance through this list. First we see a rational number, a rational number. Let me remind you, pi is irrational. The square root of 3 is irrational. Not a perfect square there with that radicand. Remember that fractions are rational, terminating decimals are rational, and repeating decimals are rational. What we want to do with this now is we want to do some practice. I'm going to ask you to classify each number as one or more of the following. We'll have natural numbers, integers, rational numbers, irrational numbers, and real numbers. Here's our list to choose from, and here are the categories we want to place them into. We'll begin by looking for natural numbers. Let's remember first what a natural number is. They're the numbers that you naturally begin to count with. 1, 2, 3, 4. So when we look at our list, very few of you said 1, 2, 3, pi, so I'm guessing that that is not a natural number. -3 is not a natural number. 2/9 is not, but I do notice that that square root of 9 right there is nothing more than a 3, which is indeed a natural number. So let's write it down. The next thing in our list is a repeating decimal, followed by a square root, which does not have a perfect square for the radicand. So our only natural number is the square root of 9. Let's now look for our integers. Remind ourselves what the integers are, the natural numbers, their negatives, as well as the number 0. As we look across our list, the first thing we see is a -3. We still have our square root of 9, which is a +3. Are there any other integers in our list? If not, let's add those two right there. We next need to look for the rational numbers. Remind ourselves what rational numbers are. They are the set of integers, all fractions, and repeating and terminating decimals. So let's look across our list. When I look at pi, it is not a rational number, but I do have an integer there, a fraction here. Remember, this is just a 3, and repeating decimals go in our group. Then I have the negative square root of 2. Well, since 2 is not a perfect square, that number does not belong in our list. So let's record those. -3, 2/9, square root of 9, and our repeating decimal, 1.33. Now let's look for our irrational numbers. Let me remind you, those are those numbers that do not terminate or repeat, such as pi and e, and also square roots whose radicands are not perfect squares. So let's look across our list. The first one we see is obviously pi. And as we look across our list, we see a square root, but remember the radicand cannot be a perfect square. 9 is, so we do not put it into this list. But over here we do have a negative square root of 2. 2 is not a perfect square, so this is an irrational number. Let me just point out to you that this sign out front is a non-issue. Had this been a negative number inside the radicand, then this would not be an irrational number. But the negative outside is not a problem. So let's add these two to our list, pi and a negative square root of 2. We next need to look for our real numbers. Let me remind you that real numbers contain both rational numbers and irrational numbers. Therefore, anything that is in this group and this group belongs in the set of real numbers. Going in order across our list, then, we would see that pi, -3, 2/9, the square root of 9, 1.33 repeating, and a negative square root of 2 are all real numbers. That's all for this lesson. Take care, and I hope to see you again soon.